Let's take everything we've been talking about and put it together in this video. Consider the square root of m to the sixth over m to the fourth. Now what I see is a fraction that can be simplified, so I'm going to simplify this first. 4 of those m's are going to cancel out, and I'll just be left with m squared. And the square root of m squared is just m. Why don't you try the next one? The square root of x to the 14th over x to the 10th. How'd you do? Hopefully you notice that 10 of those x's are going to divide out and we'll be left with x to the 4th. And x to the 4th is the same thing as x squared squared. So the square root of that is just x squared. Let's look at something similar but different. The square root of 48 p to the 7th over 3 p cubed. Now all this stuff is in the square root bar, so we can simplify this fraction. 48 divided by 3, well that's just 16. P to the 7th over p cubed, well that's just p to the 4th. We've done problems like this before. The square root of 16 is 4. The square root of p to the 4th is p squared. There we go. One more like that before we take it a step further. Consider the square root of 75 x to the 5th over 3x. Hit pause and give it a shot. Well, 75 over 3 is just 25. And x to the 5th over x is just x to the 4th. And when we simplify this, 25 is, the square root of 25 is 5, and the square root of x to the 4th is x squared. So we would just get 5x squared. Well, that's all fine and good, but what do you do if it doesn't simplify first? All those fractions simplify, but sometimes they don't. Well, let's consider the square root of 21 over 64. That's kind of weird. That doesn't really simplify well. I'll have to use this property instead. I've got the square root of 21 over the square root of 64. 21 is just 3 times 7. There's no way to really break that down, but the square root of 64 is 8. So I'd be left with the square root of 21 divided by 8. Let's try another one. The square root of 28 over 81. Hit pause and see what you can do. Remember, that fraction won't simplify. You'll have to try this new way. Well, if we think about 28, we know that it's 4 times 7. And 81 is just 9 times 9. Well, the square root of 4 is 2, so the numerator would become 2 times the square root of 7. The square root of 81 is 9. 2 root 7 over 9. Only 2 problems left, and then I think you're ready for anything. First one, the square root of 45 x to the 4th over y to the 4th. Well, there's just lots of pieces. That doesn't really change anything. We can think about this as the square root of 45 times the square root of x to the 4th over the square root of y to the 4th. And 45 is, well, that's 9 times 5. And x to the 4th is x squared squared. And y to the 4th is y squared squared. And the square root of 9 is 3. The square root of 5 doesn't do anything. The square root of x squared squared is just x squared. So I'll put that out front over y squared. Let's try one more. Then you probably got it. The square root of 80 m cubed over n to the 6th. It's an m and an n. So we've got to break it up into parts. I'll organize myself this way. 80 is 16 times 5. And m cubed is m squared times m. And then to the 6, well, that's n cubed squared. Notice how I'm thinking about it maybe in a different way than you did. Your way might not be wrong. The square root of 16 is 4. The square root of 5 doesn't change. The square root of m squared is just m. The square root of m stays the same. The square root of n cubed squared is just n cubed. So I've taken all these pieces. When I rearrange it properly, I get 4 times m, the stuff outside the square root, times the square root of 5 times m, the stuff inside the square root, over n cubed. You can do that. You can pretty much do anything as far as simplified and square roots go.